This is the video recording of the lecture Grid, Space, and Form for 2D Design Principles. Please be sure to watch the Fibonacci sequence and golden rectangle for architecture video that is located in D2L for today's class. We'll go over more about what these videos mean in the rest of this lecture. Please also watch the Finding Basic Shapes within Drawings. This is similar to some of the exercises that we're going to be doing in finding primary shapes in lines and secondary shapes in lines. So in this lecture, you're going to be learning about understanding order in drawings. We'll be talking about relational subdivision of space, location of forms and axes, diagonals regulating subdivisions, orthogonal lines that define boundaries, and differing proportions yielding different divisional geometries. So we can start out with one of these divisions, which is the rule of thirds. You may have heard of this. The rule of thirds is a composition guideline that places your subject in the left or right third of an image, leaving the other 2/3 more open and creating dynamic compositions. So while there are other forms of composition, the rule of thirds generally leads to compelling and well-composed shots. They also have a feeling of just inherent balance and aesthetically pleasing. So let's look at why. The image here on the left, we have some sand dunes and rock formations. You see a rock formation in the center of the composition. Now, when you see on the right, we have it centered on the intersection of the division of this rule of thirds grid. So we divided that composition into 3 columns and 3 rows. And the subject of that composition has been moved into along the axes there for on the left-hand side, and it takes up primarily one of those intersections. It's the nodes. This was first written down by John Thomas Smith in 1797 in his books Remarks on Rural Scenery. So Smith quotes a 1783 work by Sir Joshua Reynolds, in which Reynolds discusses in unquantified terms at the time the balance of dark and light in a painting. And Smith was an English painter and engraver and antique expert. And so he believed in the rule of thirds, and that's when that first started, when he identified it. So you can see this is far less compelling than this. The subject is not quite on, it's not on center, seems more dynamic. The division of negative space is quite different. We have more of the sky, more of those clouds showing, framing out the focal point. See all the clouds, how they're kind of focusing down to a focal point as well. So implementing the rule of thirds, there's a lot of different ways to do this. You can first look at the intersection points of those lines. You can look at the axes themselves, which just now the sample that we looked at was running along the left column axis, and the as you can see down here, this is the intersection, and that's the primary point on which the subject is kind of balanced. Okay. We also have all of the different lines. We have filled columns. You can fill a column or 2 columns or separate columns to create balance. That goes the same for rows. It also goes the same for drawing a line through the intersection points and utilizing a half of the composition on either side of that diagonal. Here are some regulating lines using, this is the rule of thirds with diagonal lines going through each of those intersection points. And this is what we're going to call dynamic symmetry, because it is a symmetrical diagram of this composition of a photograph, and it's quite dynamic. Anything with diagonal lines aligning the primary features of the composition are going to create a dynamic composition. Here we have static symmetry, where we're not really seeing the diagonal lines. All of the elements of this composition, of this photograph, are placed on the axes and on the lines and on the nodes of those lines. We don't have any of these items really being placed along on a diagonal. So when we're talking about these terms, we're talking about location of forms being placed on axes. So we're talking about the X and Y lines. Here's another diagram using regulating lines. There are, countless versions, which you'll see in a moment. But these red points, these are the intersection points. We call them nodes, N-O-D-E-S. They will be parallel to one another. They're capturing the diagonals. And the axes are a point of reference for these angles of intersecting lines. You'll learn about this more in 3D. So diagonal lines regulate subdivision within a composition. And here is how you can create some of these regulating lines. You can draw diagonal lines from corner to corner to define the center, extend the center lines along both axes, define the thirds by those intersections, by crossing those intersections. Here I'm on step 2B. You can mark thirds in both the axes. You can subdivide halves into quarter measures, extend lines from intersections of both axes, subdivide quarter measures into eighths, and extend those lines from intersections, and so on. And how might we use those? Well, here we have a really wide rectangle landscape photograph from above of a pier at the ocean. And here we can use regulating lines to find how these nodes have dictated where the cropping and where the positioning of the elements will be in this composition. So you can see we have one of these nodes is kind of capturing this negative space up here on the sand. Another is capturing the balanced space here in the ocean. Another is contributing where exactly this pier is going. Here we have another a photograph using these same regulating lines. Notice how they're just different based on the dimensions and format of the image. So the dimensions are going to be the size of the height and the width. And the orientation is going to be whether it's portrait, whether it's taller than wide, or landscape, whether it's wider than tall. Here you can see the shape of the body, the placement of the knee, placement of the face, the gaze of the eyes, all being dictated by these regulating lines, and how that has contributed to a very balanced, very aesthetically pleasing, proportionally correct structure of this composition. We do the same thing when we draw three-dimensional. So this is a one-point perspective drawing because we have the horizon line Imagine this is you're standing on a road. Here we have the horizon line. The horizon line is going to be even. It is perfectly parallel and level to the viewer's eye level. So the horizon line will change based on the perspective of the viewer. The vanishing point is basically where all lines lead and vanish from sight, where they are all basically headed toward. They never technically actually converge. Like this road is only getting smaller and smaller because of the perspective of where you are. But the vanishing point seems to be where these two lines converge. So these orthogonal lines, these diagonal lines, are headed toward that vanishing point, and they're defining the boundaries of the ground plane. Here you can see a simple sketch in 1-point perspective. Notice how these commanding lines, these regulating lines, are dictating all of these, so many of the lines in this image, like where the wall meets the ceiling, the door frame, the picture frames, the lines in the carpet, all kinds of things. Let's talk about proportion systems. There's several proportioning techniques were developed to shape architecture in different periods and different places. And they're all based on nature. So all things in nature grow according to the golden section. Seeds in the pine cone belong to a set of spirals. There's a proportion in the spirals that is close to the golden section proportion, which is 1 to 1.168. The human body grows in the same way. The arm related to the hand related to the finger, the teeth related to the other teeth and the lips, as well as the way the ear is formed. This is the golden section. This can be used in designing graphics as well. Here we have a brochure where the negative space, the subject, and the logo are divided and placed according to the golden section. Here's a business card doing the same. We have a note card and business branding. We also have a logo using the golden ratio. Art and the golden section. Here you can see we have Leonardo da Vinci's Last Supper shows all of the key dimensions of the room and table were based on this golden section, which was known in the Renaissance time as the divine proportion. The successive divisions of each section of the painting by the golden ratio define the key elements of the composition. In the one on the right, this is The Bathers of Asnières, I'm saying this wrong, by Georges Seurat. And the horizon falls exactly at the golden section of the height of the painting, and the trees and the people are placed on the golden sections of smaller sections of the paintings. Architecture and the golden section. So here we have the hypotenuse of this tetrahedron, this pyramid, which is 1 to 1.618. So regulating lines, these are the lines that indicate the common alignment of elements. They're used to control the proportion and placement of elements in architecture, art, graphic design, layouts, and so much more. They reassure the perception of order and fix the fundamental geometry of work. Here you can see regulating lines and golden ratio being used in Le Corbusier directly from the golden ratio to create the elevations of these buildings. He's a prominent architect. He proposed these regulating lines for his buildings. Once those geometric, and I'm sorry, he proposed that they would be geometric laws of any particular form, and that they should be based on this action. Once these laws are understood and the lines are drawn, various axes can be traced, and properties of forms, whether they're linear, static, or dynamic, can be detected. So according to Le Corbusier, the regulating lines guarantee fine proportions and add a rational sense of coherence to the buildings. This is the same for the classical order of the Greek and Roman architecture, following the same laws. The size of the structure, the dimension of the capitals, the columns, the space in between are all defined by these laws. So there you can see some of those laws in action right there. So Renaissance, the architects of the Renaissance, believing that their buildings had to belong to a higher order, returned to Greek mathematical system of proportions. Just as Greeks thought music to be the geometry translated into sound, the Renaissance architects thought that architecture was mathematics translated into spatial units. They applied the proportioning system developed by Pythagoras, which was based on a musical scale, and developed a progression of ratios that formed the basis of their architecture. These proportions manifested themselves not only in the dimensions of a room or facade, but also in the relationships of spaces in the plan. They applied a proportioning system based on the musical scale and developed a progression of ratios to form the basis of their architecture that shows not only the dimensions of a room and the facade, but like I said, also the spaces inside. This is the Santa Maria Novella in Florence, Italy. Here's a system called Le Modular. This is a system of human proportions in the golden ratio that defines appropriate heights for surfaces and seating, and it is based on the heights that humans will react with, based on the golden ratio that the body is created according to, that it grows according to. So here you can see different arm heights, seating heights, armrest height, and so on. Ken is the Japanese unit of measure. Modular system was first used to measure space between two columns, then used for human-sized architecture later. The proportions of the tatami floor mats are perfect for two people sitting or one person sleeping. The structure of the home is dictated by the tatami arrangement. Le Corbusier was considered by many the greatest architect of the 20th century. His name was Charles Jeanneret, and he adopted the name Le Corbusier, as it was in vogue for artists to adopt a single name to identify themselves during the era. That was his grandmother's name. Here you can see primary geometric forms: cylinder, pyramid, cube, oblong, and sphere. These basic figures would appear repeatedly in their purist paintings and were fundamentally linked with the future of the architecture by Le Corbusier. Amédée Ozoffant was a French Cubist painter and writer. He introduced Le Corbusier to the premise and objectives of the post-Cubist avant-garde. Together they founded the Purist movement, where objects are represented as elementary forms without detail. He honed his canvases closely to the prescribed rules of composition and palette. They were sharply critical of the Cubist practice of distorting objects that effectively devalued the still life painting in their view. You'll be using these for your next project. Here we have Bottle of Red Wine, 1921. These basic figures would appear repeatedly. Notice the spaces and colors, curves, and proportions of his art. Infuse the plan sections and facades of the interior and of buildings. So this is the same type of regulating lines being used in architecture as was in paintings at the time. So let's move forward. We have, we're going to take a look at observing regular and irregular forms. So here on the left, we have some very simple sketches of regular or geometric and irregular or organic shapes within a space. So diagram 1 is the two top sketches. We have intrude and erode. The figure appears to be intruding on the ground and appears to be eroding the ground of the space. So when we talk about ground, we're talking about the, when we talk about figure and ground, we're talking about the figure being like the subject, the thing that appears to be what we're supposed to look at, and the ground is the rest of the space that the figure is within, right? So the composition itself. So here we have the ground being white and the figure being black. In the next one, we see that it appears to be, like, how can we make this look like it is centered and wrapped? So as the figure defines a center of balance, the ground wraps around it, right? So the top one, it looks like it's intruding and eroding within the space or the ground. And the second one appears that the ground is wrapping around it. The third, we have traverse and divide. It looks like the figure moves across the ground and divides the field. And then number 4, we have displace and tear. The shift within the figure suggests lateral displacement while the ground appears to be torn. So what rendering effects might have an effect on the perception of such figure and ground relationships? Well, we're going to look at linear representation using tone and inverting of the figure ground. So here's linear representation. We have only lines. We have no fill to either the figure or the ground. This is going to make it more difficult to really understand or define what is happening in these spaces. It allows greater scrutiny of the edge and condition of both the figure and the ground. So using tone, some sort of light to dark value, some sort of gray or black value, somewhere in there, we're going to be able to have a lot more understanding of what might be happening within the figure and the ground relationship. Inverting figure ground is going to define an entirely different relationship. So here it looks as if the black is the figure and the white is the ground, and it is being torn away or removed from the figure. Here in dynamic symmetry, you can see the figure and the ground. So the ground here is going to be all of like the brick on the ground, really. You can see the figure primarily will be the bicyclist. That's the action shot here. In the foreground, what's closest to us, we have the staircase and the banister. Now the banisters can also be considered the figure here, because it is slicing into what we see as the ground. It's dividing the space up. So let's talk also about defined and implied space. So here we are looking at manifesting perceived relationships between the elements and geometries of the total ground as fields. So on the far left, you'll see that a space is being defined by, we have the ground, which is all of this white box area, the space that we're defining, which is in gray. The dotted line is the boundary of that definition, and the black is, let's say those are like the solid defining spaces, right? So we have these, let's imagine this is like a floor plan, and we're looking at the ground, and these black squares are representing columns. So we can look at this and consider the different defined and implied spaces that are being created. So the black squares are defining, they're defining the space. The boundaries connecting them are implying this space. So we have two different things happening. On the far left, we have the exterior of the columns implying a large enclosed space within the outer perimeter of those black squares or columns, for example. The next one, we're looking at the interior boundary, so this is smaller. The next one, we're considering the spaces defined in between those squares, between those figures. And the next one, we're looking at space implied by repetition, and how that space can be divided again and again to create a different relationship of space. And then the next one is space implied by proportion. So consider the rule of thirds in this one, for example, and how that section is being divided up into a different way. And it's proportional. So we have, for example, notice how each of these little squares that are created by these dotted line boundaries, we have one here, it actually is 2 here, 1, 2, 2 here, 1, 2, and this square would be 4 over here, 1, 2, 3, 4. So the division of that space is, it is not symmetrical like this one, it is asymmetrical, but it is proportional. So Gestalt principles, what we're going to be getting into for the next project. We've just touched on 2 of those principles. One is closure, when an object is incomplete or not completely enclosed by having the figure implying space in between its relationship with the other figures in the composition. And the figure ground is when the eye is differentiating an object from its surrounding area, trying to understand which is the figure, which is the ground. Many times they have 2 meanings. The others are similarity, where we are looking at, our mind is going to go toward what is similar in this composition. Our mind tries to automatically figure things out. It's Gestalt is it is a psychological interpretation. It's a philosophy of your mind trying to make harmony out of what it sees. That the sum of all of the parts is more than the parts by themselves. And so here, we do that in different ways. So similarity is one of them. We automatically look at these three top compositions, and we automatically categorize what is maybe circular or maybe a different color. Proximity, we're looking at items that are close together, and we are considering them to be a grouping. So if you look at this one, for example, on the far left, we see a bunch of squares, but we see two collections of squares. The one on the far right, we see 3 columns, not just 12 squares. Space is, like I mentioned, either well-defined or loosely defined, but it is we're not fully closing off the boundaries. We are somewhat closing the boundaries for the implication of space in between the figure and the ground. So here, when we add space and value, value is going to be tones from white to black. So all of these different gray colored tones or values will create form. So on the left, you see 4 different figure-ground relationships, and the top left is quite loosely that we have like column perimeters here, just on the perimeter, and it's a loose closure. Now look at the different relationships, and then on the far bottom right, we have a nearly fully enclosed space with a few columns as like an entryway. So on the left half of this page, you can see figure ground in 2 dimensions. Then if those planes were extruded up through space, and that were a 3-dimensional relationship, you would see such space and columns and walls and things created in hallways and openings. All of those things would be created in 3 dimension. Well, here we're adding space and value to imply the form. This is still a 2-dimensional drawing, but we are implying the form. So here we're going to define figures and shapes. So you're going to be doing this in your exercise. So on the left, you see a grid that has been created. 4 horizontal lines drawn across those lines and intersection points. Then on the right, you can see 2 resulting figures. So if we add value, like a full black in between 2 of those lines, the thinly paralleled and the widely paralleled, then we have a figure-ground relationship. And those seem to be becoming the figure. Now a gray value is being added to imply a form. So we are also using these gradients to identify these like axial domains for spatial gestures, right? So imagine this is a floor plan and we're looking down on this defined space, and we're going to add this gradient of value, this gray coming off of the black, to imply that this is a form if it were in 3 dimension. Here you can see what I mean. So we have the aligned figures in the defined field on the left, and then if that were in 3 dimensions and those planes were extruded through space, you would see these forms. So our in-class exercise is going to be making a 6-inch square in your sketchbook and creating a grid within it. You can have 1/2-inch spacing, 1-inch spacing, or spacing with no equal distances. You can make it varied, you can make it very dense. Just consider the more grid intersections that you have, the more more lines that you have, the more opportunities you will have for utilizing that grid. Then you're going to take that grid and you're going to put your trace paper on top of it. You're going to connect the nodes, which are the intersection points, creating complexity in the space. And you will define different variations of space. This says 5, we're doing 10. I wanted to show you one more thing. This is some examples of how you can use different scribbling, stippling, hatching, cross-hatching, and things to create value. So remember we said we're going to add value to create form? Here's different ways to do that. So we have light on the left to dark on the right. So those are different levels of value. Okay, I'm going to head over and make your grid demonstration video. You can watch that next.